Is ARP4761A the same as HARA? At first glance, both seem to do the same thing. They analyze safety risks at system level. But the way they approach this is fundamentally different. One is used in aerospace, the other in automotive. One relies on multiple analysis methods. The other follows a structured risk model. In this video, we compare ARP4761A and HARA and explain when each approach is used. Why should we compare ARP4761A and HARA? Both approaches address safety at system level, but they come from different industries. ARP4761A is used in aerospace. HARA is used in automotive. Because of this, they are often seen as completely separate, but in reality, they share similar objectives. Both aim to identify hazards and reduce risk. At the same time, they use very different methods. Understanding these differences is important, especially as systems become more complex and interconnected. Let's briefly recap ARP4761A. It is a guideline for safety assessment in aerospace. It uses multiple analysis methods, such as FHA, FTA, and FMEA. The focus is on identifying hazards and analyzing failures. These methods are applied across the system lifecycle, and they support both design decisions and certification activities. Now, let's look at HARA. HARA stands for Hazard Analysis and Risk Assessment. It is defined in ISO 26262. HARA identifies hazards in automotive systems. It then evaluates the risk based on three factors: severity, exposure, and controllability. Based on this evaluation, an ASIL level is assigned. This determines the required safety measures. So what are the key differences? The first difference is the approach. ARP4761A uses multiple methods, such as FHA, FTA, and FMEA. HARA, on the other hand, follows a structured evaluation. It assesses risk based on severity, exposure, and controllability. Another key difference is the analysis style. ARP4761A combines top-down and bottom-up approaches. HARA is more scenario-based. The outputs are also different. HARA defines ASIL levels and safety goals. ARP4761A provides detailed analysis results. Another important difference is the underlying mindset. In aerospace, the focus is on failure analysis. Engineers try to understand how a system can fail and why. This leads to detailed investigation and multiple analysis methods. In automotive, the focus is more on risk classification. Scenarios are evaluated, and risks are categorized. This results in a more structured and standardized approach. These differences reflect different engineering cultures and regulatory environments. But both approaches aim to achieve the same goal: safe system behavior. Let's look at a simple example. Imagine a sensor failure during operation. In aerospace, this would be analyzed using ARP4761A. Engineers would identify possible failure causes, then analyze fault paths, for example using fault tree analysis. And finally, they would assess the system impact. In automotive, the same situation would be handled differently. The hazard scenario would be defined. Then the risk would be evaluated based on severity, exposure, and controllability. And finally, an ASIL level would be assigned. This example shows how the same problem is approached differently. So how do these approaches fit together? It is important to understand that they are not competing. They can actually complement each other. ARP4761A provides deep analysis methods to understand failures in detail. HARA provides a structured way to classify risk. In complex systems, especially across domains, both perspectives can be valuable. Combining detailed analysis with structured classification can improve safety. So understanding both approaches gives a more complete view of system safety. There are several common mistakes when comparing ARP4761A and HARA. One of the most common is treating them as identical, but they are fundamentally different in their approach. Another mistake is applying one method in the wrong domain. Each approach is designed for a specific context. Some also ignore the differences in objectives. This can lead to incorrect conclusions. Another common issue is oversimplifying safety analysis. Safety requires the right level of detail. And finally, system context must always be considered. Let's summarize the key points. ARP4761A and HARA both address safety at system level, but they use different methods and approaches. ARP4761A is used in aerospace, while HARA is used in automotive. Understanding both provides a more complete view of safety, and choosing the right approach is essential for ensuring safe system design. If you want to go beyond this comparison of ARP4761A and HARA, we offer a wide range of online training programs on our website. In aerospace, we cover system development, software standards like D0178C, and safety assessment based on ARP4761A. In automotive, we provide training on functional safety, SOTIF, cybersecurity, and development processes such as ASPICE. We also cover medical devices, where safety-critical development and regulatory requirements play a key role. All courses are designed to be practical and applicable in real engineering projects. You can find the link in the video description and in the pinned comment below.